So anyway, welcome everybody. My name is Larry Olson, and I'm going to be kind of the facilitator tonight. We're meeting here in the library because we wanted to, hello, good to see everybody. So we wanted to have a conversation, and when you're in the chapel with the benches and everything, it's a little one directional. So we thought that being in the library might facilitate a little more discussion. So that's why we're here. What I'm going to do is spend just a few minutes. I've got a few slides, so I'll share my screen here just to kind of get us started, kind of set the tone. And then we'll stop and have some conversation. And depending on what questions you want to talk about, I've got a few more slides if we want to. I've got some slides that deal with water and power and some things like that. But mainly it's a matter of trying to have some conversation. So let me go ahead and share my screen here and we'll get started. Okay, so our topic tonight was what is happening to our Earth, and we wanted to look at various environmental issues. We didn't specify exactly which ones, but the idea is that our Earth's environment is changing. It seems to be changing pretty rapidly right now, and in many cases, not for the better. And so we want to take a look at why that might be happening, and specifically, what might we do about it? What can, is there's something we can do to help counteract that? We want to start, first of all, by saying the Earth's environment has always been changing. 4.6 billion or however long it was that the Earth was formed, it's been changing forever. So there was a time when the Earth didn't have any oxygen in its atmosphere. There was a time when most of the Earth was covered with ice. And there's a time when very little of the Earth was covered with ice. And none of that had anything to do with humans. So there are natural reasons why the Earth's environment should be changing. And that's one of the things that makes it a little bit hard. Are the changes that we're seeing, are they due to natural reasons or are they due to human factors? And there's some argument and discussion about that. So we'll talk about some of that a little bit. I want to tell you that, first of all, tonight, I've got some good news and some bad news. So let's start with the good news. One of the things that we want to talk about with respect to humans affecting the Earth's environment is that didn't happen for a long, long time. I don't know when humans first started. Tina's interested in prehistoric, and she's always showing me videos and articles and things like that. So 500,000 years ago, 1,000,000 years ago, whenever you want to talk about Homo sapiens, dominating the Earth, they were basically hunter-gatherers, and they didn't have much ability to change the environment, except maybe just around their immediate area. Maybe they could cut down some trees. Maybe they could, clear a little bit of area for some shelter, but they weren't changing the world's environment. And that didn't happen for a long, long time, primarily because we just didn't have the tools to be able to do it. I like this chart because notice it's not on the x-axis, it's not even. You go 500,000 years and then 10,000 years. So, but even about 10,000 years ago, there wasn't much. That was during the time of cave art, the Lascaux in France and other places, that's 30,000 years ago. They were human groups around, but they weren't really doing much to change the environment. It really wasn't until agriculture started, which on this chart is somewhere around, that's 8,000 BC, so somewhere around 10,000 years ago that we started doing agriculture. We didn't start doing it on large scale until we started doing irrigation and plowing and things like that. That's when we really began to have an ability to impact the Earth's environment. But then the other thing that happened was we began to learn how to use metals. We began to smelt metals. So we've got the Bronze Age and the Iron Age, and people began to start early kinds of industry. But again, that was 4,000, 5,000, 6,000 years ago. And it was affecting local areas. So if you were in an area where they were doing some copper smelting, that might not have been a real fun place to be. You know, the air might not have been very good in that particular village. But it wasn't affecting the whole air, you know, the whole region. It wasn't affecting the earth as a whole. So we really didn't have the tools to do that until the industrial age, which you see there on the far right. And that started somewhere around 1760. So basically the beginning of the American Revolution. Just think about the industrial age as, you know, American Revolution times. And that's with Isaac Watt and the steam engine and stuff. And that's when we first began using fossil fuels. First of all, coal. We began digging up coal. And then we didn't have any use for oil back in the 1800s. We didn't have any use for oil until we had cars. And then all of a sudden, oil was valuable and natural gas followed. So beginning in the 1800s and the 1900s, we began to have the tools, the ability to impact the Earth's environment in a much bigger way than we had ever had in our history. But the other thing that happened is, look at that red line. In 1800, is actually 1804, if we look at this slide, 1804, the estimate is that's the first time we had 1 billion people on the earth. That's the time of Thomas Jefferson being president. It took until 1927 for there to be another billion added. Now that's an important date for me because that's the year my mom was born, 1927. I was born in 1948, about halfway between 27 and 60. So when I was born, there were maybe 2.5, maybe 2.6 billion people on the earth. What is it today? As of May 2023, the estimate is 7.96 billion. The human population has tripled in my lifetime. Tripled. That's never happened before. We've never had a time when the population's been growing as rapidly as it has. There's lots of reasons for that. Agriculture, industry, we had the ability to feed way more people, take care of them, all kinds of different reasons for it. But the combination of those two things, the tools and the number of people, has changed the way humans have interacted with the environment. So any questions, stop, interrupt me. This is not anytime you have a slide or question. And medicine, yeah, medicine. People's lifetime really began to increase, especially after we discovered penicillin and antibiotics and things like that. Yeah, germs and childbirth was terribly, huge percentages of fatalities in childbirth until just very recently. So there's lots of reasons for that. But for us to think that could go on without having any impact, this is huge. This is huge. So what's happened? Well, I said I had good news. That doesn't look like good news, does it? That picture was taken in 1969. That's the Cuyahoga River in Cleveland on fire, literally on fire. Now, how can a river be on fire? Yeah, it can't be. The water's not on fire, but the oil sheen on top of it from industry. There's lots of industry right there along Cleveland. Maybe some ships had lost some fuel or whatever, or discharged their bilges or whatever. Anyway, there was an oil sheen on the Cuyahoga River and it caught on fire. And this picture was, and other pictures like it, Life magazine and all over, got a lot of publicity in the United States. The mayor of Cleveland went to testify in front of Congress and he said, "This is ridiculous. We can't have this, but there's nothing that I can do as the mayor of Cleveland to change it. I don't have the ability to change industry and change the way they discharge. There needs to be national laws that affect that." This picture was really one of the things that began the environmental movement. This was 1969. In 1970, the EPA was founded, Environmental Protection Agency. And that began a whole series of laws. In 1970, the Clean Air Act was passed. In 1972, the Clean Water Act was passed. In 1974, Safe Drinking Water Act was passed. Lots of other things, all starting in the 70s. It took decades, but it had an effect. So even though that doesn't look like good news, it actually is good news because it got us to say, we got to do something about this. We can't just keep having our rivers burn up on us.
Very interestingly, that was bipartisan
It was. Who was president in 1970? President Nixon. Now, you can write it pretty good. Nixon was the president when the EPA was founded and the Clean Water Act. And the thing was, he wasn't supportive of it, but it did happen on his watch. It did happen. So yeah, and the fact was, it was bipartisan. There was a real bipartisan effort to say, this is ridiculous. We got to do something about it. The other thing, water pollution was horrible. Air pollution was horrible. I remember driving into LA in the 1960s and it looked just like that. Pittsburgh looked just like that. Yeah. Monongahela River, all the steel mills along Pittsburgh, and coal, coal burning power plants, all kinds of things. So, and Phoenix looked like this. I remember I went to college in 1966 and there was a strike in the copper mines in 67, I think, something like that. The copper mines had always said, we don't affect the air quality in Phoenix. Nothing we're doing is affecting the air quality. Guess what? The air quality in Phoenix was a lot better during that copper strike when the smelters were shut down. When the smelters started back up, boom, it was just back to the way it was. So all over the country, the air quality looked like that. And again, this was part of the problem. We got to clean up our air. We got to clean up our water. Well, we did. Here's some data that shows you that. One of the pollutants in air pollution is carbon monoxide. This is starting in 1980. And that dashed line there where it says national standard, that's what's called the National Ambient Air Quality Standard. And it's for carbon monoxide, for sulfur dioxide, ozone, et cetera. Each pollutant has its own standard. And so back in 1980, there were large parts of the country that were out of compliance, not with carbon monoxide. Phoenix was one of them. We were one of the last places in the country to get into compliance with the carbon monoxide standard. The black line's kind of the average. So the shadow there is showing all the different areas. Some were high, some were below. The black line is the average. And so what's happened now is there's no place in the country that is non-attainment for carbon monoxide. Every place is meeting the carbon monoxide standard. That didn't just happen. How did it happen? How do you think we did that?
Somebody started the movement.
Well, they passed some laws, but one of the biggest sources of carbon monoxide poisoning is cars. Back, those 1960 muscle cars, they sounded great. They looked great. They went really fast. They were horrible polluters. What kind of car did you have in the 60s, Dan?
Ford.
Ford? Okay. Okay. A Mustang 2+2 or whatever. If we were still driving the cars of the 1960s with as many people in Phoenix, nobody would live here because you couldn't. They were just one car back in the 60s. I didn't look this up, so don't quote me, but it's worth hundreds of cars now in terms of the amount of pollution that one car was putting out versus what cars are putting out now. Now, they didn't do that out of the goodness of their heart. They were forced to by the law. So what happened was every year we'd look at the manufacturer and say, you've got to decrease your emissions. And so what did they do? They did catalytic converters. They did, when computers came on, they did, more computerized emission controls, things like that. And it worked. It wasn't. And unleaded, yeah, when you did catalytic converters, you had to then put in unleaded gasoline, which turned out the reason people took lead out of gasoline was not because lead was dangerous for people and everybody was worried about lead was going to make you sick and all that stuff. No, it was because it was dangerous to the catalytic converter. It was going to poison your catalytic converter. That's the reason they took it out. But the unanticipated, well, not unanticipated, but the beneficial effect of that is the amount of lead in the air and in the roadways decreased dramatically when we took lead out of gas. It's invisible. Nobody really knew it was there, but it was. And it was affecting people. It didn't just happen, though. We made up our mind to do it. It took decades. It took a lot of money. There was political arguments. It wasn't always bipartisan, but we did it. Here's just a couple more. Sulfur dioxide. Now, that doesn't come out of your cars unless you're driving a diesel engine. And back in the old days, remember those big diesel trucks with all the black smoke coming out? Well, one of the problems was the diesel fuel back in those days had a huge amount of sulfur in it. And when you burn that sulfur, it comes off as sulfur dioxide. So diesel engines were responsible for a lot of sulfur dioxide. What do? We forced the amount of sulfur in diesel fuel to be decreased to 15 parts per million. Now, it used to be that diesel fuels were cheaper than gasoline. Now they're more expensive. Why? Because they got to do a lot more refining to get all that sulfur out of it. But it's had a huge impact. The other thing that happened was the other big place that sulfur comes from is from burning coal and from smelting things like copper. And it used to be all that sulfur dioxide just went up the stacks. There were no scrubbers. We forced industry to put scrubbers on there. If you're going to burn coal, you got to scrub the sulfur dioxide out of it. You can't just burn it. And that's the effect. So we're basically in compliance around the country now with sulfur dioxide standards. Now, ozone's a little bit different. It's been a tougher nut to crack. So we're doing better. You know, the amount of ozone in our air is decreasing, but there are many places in the country that still are not in compliance with ozone, and Phoenix is one of them. It's not too surprising. Ozone is a photochemical reaction, and in hot places like Phoenix, that reaction is accelerated. So we're one of the worst places for ozone in the country. But it's a little misleading because the other thing they did was they kept lowering the standard for ozone. So it's like they moved the goal line. I get up to the 20-yard line. I'm almost there. Oh, we're going to extend the goal line another 10 yards. And the reason for that was they kept discovering ozone was really bad for you, bad for your health. And so there was a process that went through, but the ozone standard has gradually been lowered. And that's one of the reasons it keeps getting harder and harder to meet, is because they keep lowering the standard. So we're making progress, but we're not quite there. But there's unambiguous data. I didn't show you all the data for water quality and stuff, but that's true too. The water quality in the United States is much, much better than it used to be. That doesn't mean that there's not problems. Where are there some problems now with water right now? Flint, Michigan, what's wrong there? Got lead in the pipes. Yeah. Where else? Mississippi has got water problem. Jackson, Mississippi. What is the comparison between Flint, Michigan and Jackson, Mississippi? What's common about those two?
Common denominator?
Yeah, common denominator. Yeah, lower economic. The bottom of the no power. And guess what? For decades, their water was ignored. Other people in Mississippi have good water, but not the people in Jackson,
So
Mississippi.
I have an observation. My daughter lives in Mason, an apartment complex, and had a note on her door that their water isn't drinkable. They have some available somewhere on the property, but they're not required.
Did they say what it was?
Probably I didn't get that information. I should have had her click a picture, but I thought that was just absurd that Mesa had apartment complexes that may not be required to deliver drinkable water. Is that possible? Or did she misunderstand a letter?
Well, anytime you have a water supply organization for more than 15 families, 15 hookups, they are subject to the federal Safe Drinking Water Act. So that means that every place in the country that if you're just got a well in your backyard out in Timbuktu, then nobody's testing your water. You're not subject to any federal standards. But if you're serving more than 15 people, then you got to meet all those standards, which means that requires regular testing, and it requires a set of contaminants that you have to test for.
Sure. So it's probably just the testing
So
failed.
my guess is that what's happening, my guess, I don't know for sure, is that one of those tests came back positive above the standard, and it's a temporary thing. They're saying right now, we don't know what's going on. And it depends on what it is.
Right.
It depends on what it is. In Prescott, one of the problems, which is where Tina and I live, depending on where you live in Prescott, if you're out by the airport, there are certain wells in Prescott that have been testing just recently for higher than the regulated standard for PFOS, which is polyfluorinated alkyl substances. And basically what it is carbon and fluorine attached together to make different kind of compounds, like Teflon. but they make all kinds of things like fire retardant materials for your sofa, for clothes and all that kind of stuff.
You get to go the like silky stuff on the inside of the styrofoam. Yeah.
Okay. So the thing about it is, in nature, there are no carbon fluorine bonds. So if you see a carbon fluorine bonds, that was human made. Somebody made that. It doesn't occur in nature. Unlike arsenic in your water, things like that, it's naturally occurring from minerals in the ground. And so the problem with that is people know that there are some health concerns about PFAS. Right now, there's no actual standard. Certain states have set some actual levels. And you say, well, how come they haven't set a standard? Well, one of the reasons is that the concentration of it is parts per trillion. 10 years ago, we didn't have the ability to measure parts per trillion. If you're going to set a standard, you have to be able to measure. And, you know, unless you've got the technology to do that, then, you know, you can't really set a law. And the other thing is, in order to set a standard, there has to be lots of different kinds of data that shows the negative health effects. And it has to be, you know, I mean, think about it. So Don, you come up with a rash or something like that. Can I say that that's due to PFAS in your drinking water at parts per trillion level? Well, you're exposed to all kinds of things. You know, you got to do certain kinds of studies that say everybody's the same, except these people were exposed to PFAS. That's expensive, it's time consuming, and you don't want to just say, well, what happened after 6 months? Maybe it doesn't occur until years later. So setting these standards, whether it's air pollutants or water pollutants, is a difficult, expensive process.
They will be contested.
And they will be contested. Everything's going to be in the law. So there is going to be a standard for PFAS, but that's one of the examples of an emerging contaminant. And maybe that's what maybe they said, because that's been in the news a lot, and there's been a lot of different water companies. Probably they should have said, you can't drink this water. They shouldn't have said that because it's not actually violating a standard, but it's good for them to let you know that there's been a test that detected this level. Then you can decide whether you want to drink it or not. But if there's higher than accepted levels of arsenic, for example, then yeah, they'll say, no, don't drink this, or other kinds of contaminants. So the main point of this, though, was we've had a lot of success in the last 20, 30, 40 years. I mean, 1970 was 50 years ago when the EPA was founded, but there's been a lot of success. Our environment is much cleaner. It's not perfect. There's a lot of problems, and not everybody has access to the same high quality water and food and air that other people do. Sometimes when you talk about citing industry, where does industry cite? Do they cite on Lincoln Avenue here? You know, right next to the church? That's not what they're going to go. They're going to go where the land is cheaper, which typically means that's where poor people live. And so there's something called environmental justice, which is poor people are abnormally affected by environmental pollution, more so than most of us sitting in this room, just because of where they live and where their drinking water source is. And that's a whole nother story. That's a big deal. But the good news is we have done some positive things. So the idea that, well, there's nothing we can do, you know, it's all beyond any of our ability. It's not really true, but it takes commitment and money and time. It doesn't happen overnight. It can take decades. But we're actually living in a much cleaner environment than we used to be. And that's good. That's what's called conventional pollutants. So things like air pollution, water pollution, ozone, you know, solid waste, trash heaps, and things that you're not treating your waste in a proper landfill and stuff like that. Even things like even things like plastic in oceans and stuff, that's conventional pollution. For the most part, we've been doing pretty well. Anybody have any questions about that or about what we've been talking about so far?
When the video is posted, I'm assuming we can put up, I'm sure Jeremy can figure it out, but it would probably be good to put up some of your slides.
Those will be-
Yeah. Well, the video will include the slides. Yeah. Yeah.
It's recording it just as you.
Yeah. Yeah. So anything we're seeing will be on the video. but we could attach them if we need to. So I guess if we were talking about what's happening to our environment, I would be pretty positive about it with certain exceptions. It's not true across the board. We need to do a better job in poor areas. There's no reason why in this country, Jackson, Mississippi ought not to be able to have drinking water out of their tap. That's crazy. And I don't know all the details with that, but it's, they can fix that if they want to. This is not an insurmountable problem.
The progress has been spotty. It's much different in the US than it is in China and India. Very populous countries.
That's a great question, Don. So if you didn't hear Don, he said the progress around the world has not been necessarily the same as the progress in the United States. That the environment in China, the environment in India and other places around the world may not have improved nearly as much as it has in the US. And that's true. But China's been a real interesting case study because when did Nixon go to China? Remember that? It was right before he resigned. So that was 1974, August of 1974. And so I think it was maybe January 74, something like that. Mao Zedong was still, in power. And so China was still very communist oriented in terms of controlled economy and, no free market or any of that kind of stuff. But when Mao died, and Deng Xiaoping came into power, they started that process of going to a more market economy. So they were trying to combine capitalism and still have their Chinese communist imprint on it. And it turned out it was hugely successful from an economic standpoint. So China's economy just went, excuse me? Most of the steel mills, yeah. It wasn't just steel mills. It was all kinds of different things. Yeah. Exactly. When all of our industry went to China, our pollution went to China with it as well. And China was horribly polluted. Air, water, and they were almost totally dependent upon coal initially for their electricity. And they weren't putting any controls on the coal. They were just spewing all the smoke out of the stacks without any kind of capture devices. And so the people, as they began to get out of the pure poverty and into the middle class, began to rebel. They did the same thing that we did when we saw that picture of the Cuyahoga River and said, we need to do something about this. And they forced the government to start trying to pay attention. Now, China's still way behind the US in terms of their environmental quality. They have the laws on the books. They have actually gone ahead and passed a lot of laws that look very similar to ours. Their enforcement isn't nearly as good, but they have made some improvements in both water quality and air quality. It's still way, way below what it is in Western Europe. But what's interesting is that as people begin to get richer and more middle class, where they're not just concerned about survival, they turn and say, you need to help clean up this environment. I need clean air and I need clean water. And they did that in China. India is behind even China. So they've got even a further way to go. But you're exactly right. It's not universal across the world. But as the economy improves, one of the things we see is that there's more and more pressure to improve the environment. Other questions? Anybody watching online that has anything you want to add? You can either put it in a chat box, or if you've got a microphone, I think we'll be able to hear you if you want to say something.
Hello.
Hi, we can hear you. Any questions?
Nothing yet.
Okay. All right. Well, if you got something, just jump in. Yeah.
8 participants.
Okay.
Only show the ones with their video turned on.
Okay. Okay. Well, anyway, if anybody has any questions online, please put them in the chat box or unmute your microphone and speak out. But let me go ahead and talk about Whoops. Here. The other big bugaboo that we're dealing with. So there's something different about climate change than what we call conventional pollution. And so when we talk about what's happening to the Earth's environment right now, most of what you're hearing about right now deals with impacts on climate change. And that's different from trying to control ozone or trying to control lead in you know, your water pipes or mercury and your air or that kind of thing. So let's talk about that a little bit. What kind of evidence do you think we have about whether the Earth's climate is changing? What kind of evidence would you look for? What do you think would be a good thing to look for? See,
The seasons are changing.
explain that a little bit. What do you mean seasons are changing?
Well, they're not starting. and
Okay.
ending where they normally do.
Okay, so if
Be
you-
able to well, it's kind of harder for Phoenix because we don't have the big.
Yeah. you have two seasons, you have summer and almost summer.
Yeah. Summer and
Yeah.
spring.
Yeah.
And the things that are the 4 seasons, but they're moving.
Yeah.
You know, they're.
Yeah. Farmers, right. Farmers are observing that. Other things that people are observing is certain crops that grew in certain parts are not growing well there. Or sometimes they didn't used to grow there and now they are growing there. So sometimes it can be a good thing. I'm able to get more crops, especially for people up in Canada or whatever. Their growing season might be a little bit longer than what it used to be.
Some of the good French wines are now being grown
In England, yeah, yeah. Yeah, you want some real good French wine, go to England. All right, exactly. All right.
Ice pack could be another.
Okay, so another thing you might look for is what's happening to the ice. Anybody know what's happening to ice packs? Yeah. Where are they melting faster? North Pole or South Pole? Yeah. The Arctic seems to be losing ice at a much faster rate even than the South Pole. Both of them are losing ice, but the North Pole is losing it at a dramatic level. What else might you look for? Yeah, ocean temperatures are getting warmer, which would be probably due to the air temperature getting warmer. So temperature is going to be a big deal, both temperature over the land and temperature in the oceans. Why would ocean temperature change? Why would it be important that the ocean temperatures were changing? What effect would that have?
Sea life.
Okay, it could affect the sea life and the food chain. And like coral reefs could be,
Our
you know,
weather.
they're actually living organisms, and so we're losing a lot of coral reefs. Jeremy?
The weather
Okay, yeah, the weather is a huge thing, though.
affects the air above the ocean.
How come we had such a big winter with snow and rain this winter? How come that
Temperature
happened?
in the Pacific Ocean was
We didn't used to know, when I was in high school, when you were in high school, Dan, we didn't know that the ocean temperatures were dramatically affecting our weather in Arizona. We didn't really understand how all that was happening. But now the ocean temperature changes a little bit, and that changes the atmospheric winds so that it dips down from the Arctic, or it doesn't dip down from the Arctic. That's going to make it rainy and hot, or rainy and cold here, or it's going to make it hot and dry here. And it has to do with what's the ocean temperature in the Pacific Ocean. We didn't really used to understand that. So changes in ocean temperature have huge impacts beyond just what's living in the ocean. It has an impact on our water here in the Southwest.
Larry,
Yes,
haven't we always had El Nino and La Nina? Which
we
are-
haven't always called it that, and
Well,
we,
but
we
we've
haven't
had it-
necessarily tracked it, but it's
Well,
been there.
We've had it since I've been here, and I've been here 50 years,
Yeah,
60.
60 years maybe. And El Nino and La Nina does affect, has always been,
okay.
you know, one of
Let-
the things that the weather people at least tell us affect, you know, the climate in Arizona. So I think I would just offer the fact that I believe that we have recognized that the ocean temperature does have an effect on the climate in Arizona.
Let me share your comments because not everybody here in the room could hear you. So what he's saying is, haven't we always had El Nino and La Nina? And he's saying, you know, for the 60 years he's been living in Arizona, you know, he's been aware of that. And yeah, that's been there. It hasn't always been tracked as much as we've been tracking. It hasn't certainly been in the public knowledge as much, but that's not a brand new thing, that the ocean temperatures have changed. You know, that there's a seasonal effect, you know, a multi-year effect. There are years when we have El Nino, years when we have La Nina, and that can affect our weather here.
Well, and the other thing I was going to say, is that you know, we've always talked about the fact that an El Nino year should bring, you know, more rain, for example, in the springtime, where La Nina is typically associated in Arizona with a drier year. But if you look at the correlation between those events in Arizona and, you know, what they call an El Nino and La Nina year, the correlation is certainly not one. It's actually probably more, only like 0.6 or 7. It's not extremely well correlated. So I mean,
Right. So
there's just a lot of you know, as far as ocean temperatures affecting weather, that isn't, I don't think that's a given. I think that's a theory that may have some validity, but I don't think that's been proven.
well, yeah, so there's certainly not 100% correlation. Every El Nino year is a really wet year, and every La Nina year is a really dry year in Arizona. That correlation isn't 100%. What happened this year, apparently in the West here, is that, remember, we had all these atmospheric rivers coming in from California, one after the other, dozen or 2 dozen. I don't remember exactly how many other than there were. It seemed like they'd never stopped. And when those hit California, some of those get here to Arizona. So California was having some record atmospheric rivers in terms of both the number and the quantity of water that was dropped over the state. How in the world could global warming be a cause for heavy record snowfalls in the Sierra Nevadas in California? How could that be? Does that make any sense?
Oh, it really evaporate more ocean water.
Okay, one thing we know is that when the air temperature is warmer, the air will hold more water. So as the air temperature warms up, there's going to be more water and a certain amount of air. And then when it cools back down, that water can't stay in the air anymore, so it comes down as precipitation. So if the oceans are warm, there's a lot of water in the air over the oceans. As they get blown over California and they get to the mountains where it cools off, that water's coming out as snowfall. So ironically, it's possible that higher air temperatures over the ocean could potentially, depending upon everything being right, could potentially be responsible for those atmospheric rivers that dumped all the record snowfall in the Sierra Nevadas and in California. I'm not a meteorologist. I'm not an expert in all that. So I may be wrong in some of these things. I'm a chemist. So that's not my particular area of expertise, but it makes sense that more warm air contains that's definitely true. Warmer air contains more water. And so when that water does precipitate, it's more intense storms. And that's actually one of the things that climate change predicts: more intense storms, sometimes more intense snowstorms. Kind of weird. Global warming could cause more intense snowstorms. Potentially, there's an explanation. Let me just show you a little bit here. That's data for the Earth. Now, that's not just Arizona. That's not just China. This is global surface temperatures. And it goes back to 1880 because that's about the earliest we have any actual recorded data. So these are actually people out on ships and stuff like that taking measurements from the 1880s. What does that chart say to you? I mean, what? Just give me an impression. Yikes. Okay, that's one. Anybody remember from, I know one of Tina's favorite classes was statistics. It was such a favorite class she had to take 3 different times. Not the same, she didn't fail it. It was one as an undergraduate, one as a master's student, and one for a doctoral program. I got to clarify that. Let me not say it like that. I got to be careful. But that is not a normal distribution. You know, a normal distribution, you have some hot days, you have some cold days, but the overall average isn't changing very much. You look at a distribution like that, and what do you think is happening to the average? It's getting warmer. Now, you can argue about why it's getting warmer, but there's not a whole lot of argument that it is getting warmer. The 10 hottest years on record have all occurred in this century. And this goes back to 1880. So that's one thing. You talked about temperature would be one evidence of climate change. Okay. Well, I mean, yeah, we're not saying why that's happening right now. I'm just saying it does appear, and this is going back to as early as the recorded temperatures, humans actually measuring temperature, that the Earth is getting warmer. And it's accelerating. It's not slowing down. It seems to be speeding up. Here's another piece of data. That is actually Lake Powell. What is that telling you? That's the bathtub ring on Lake Powell.
Be a lot higher.
That's about 170 feet between the top and where the water is right now, about 170 feet. So the water level on Lake Powell right now is about 170 feet below where it used to be. Why is that happening? Because according to people that look at things like tree rings and other kinds of climatological data, we're in the midst of a 1,200-year drought. Now, that doesn't mean we don't have some wet years. This is a wet year. Thank goodness. Thank God. Praise God. We had a great winter. Hopefully we'll have a good monsoon and a good summer. But overall, 1 or 2 good years. Now, if we have 10 or 12 good years, then that maybe gets us out of the drought. 1 or 2 good years doesn't get us out. So this seems to be one of the worst droughts that has been in this part of the region in a long, long time, more than 1,000 years. And it started about 1999, we think. I'll show you some data here. That's Lake Powell. This is Lake Mead. Of course, Lake Mead, the level of Lake Mead depends upon the level of Lake Powell, because Lake Mead only gets water that comes out of Lake Powell through the Grand Canyon. But both of those are record lows. And what's important is these columns here, that's where you get your water out of. That's what goes through some of the power turbines. And we're getting close to the point where you can't get water out to turn those turbines anymore. And below that, we're getting close to the point where you can't even get water out of the dam. Here's a chart that shows you that. Yeah, for the turbines. So here's Lake Powell. I remember we went on vacation when I was a kid in Oak Creek, and I remember cement trucks going past the motel we were staying at in Oak Creek, going up to Glen Canyon Dam all night long. That was back in the 1964, 63, that era. So they started filling Lake Powell in 1964, and it got full. 3,700 feet above sea level is full. It's been full twice, once back in the 80s and once in the 90s. And then starting about 1999, it started dipping. On this chart, it stopped in 2021, and it was at 34% capacity in June of 2021. In April of 2023, that's last month, it dropped down to 35.20. So you can see this is about 35.60 right here. But in the next year, couple of years, it's dropped down to 35.20. That was the lowest point that had been since all the way over here when they were filling it. And why is that important? 3520 is just 30 feet above the level at which you can't get water into the turbines to produce power anymore. That's
Barry,
how low it is.
I have a question.
Yes, please.
Has the outflow in all those years been constant, or has the outflow, in other words, the amount of water that they've been taking out of it, has that been increasing as the population, for example, of the river has increased, or is it?
Somebody, Don, did you hear?
The amount of
Does that make sense?
Oh, no, they've actually been trying to save water in Lake Powell. You know, it's been a balancing act between water in Lake Powell and water in Lake Mead. But because they're getting so close to not being able to turn the turbines in Lake Powell, they've been trying to save it. So this dramatic drop has not been because of human factors. It's just been because the inflow has been way below what had been normal. So there's several reasons for that. One is the flow in the Colorado River, the amount of water coming into Lake Powell has been less than what we thought was the historical average by quite a bit, by 20–30% less than what we thought was the historical average. And one of the reasons for that is that it hasn't rained or snowed as much. But another reason for that is it's gotten warmer. And snow can do a couple of things. When you've got snow on the ground, it can melt and run off and get into a river and flow into Lake Powell. But the other thing that it can do is it can evaporate. We call it sublimation. It can go directly from snow into the air. And that happens when it gets warmer. And so there's been a less amount of, even though we've had some years when it's been decent snow, it's been warmer and the flow, the runoff hasn't been as good because it's been so warm that the snow's been sublimating and getting into the air. And then the third thing that happens is if the ground's been real dry for a long time, rather than run off, it sinks into the ground. And so if you've got a good snowfall after 2 or 3 really dry years, you're not going to get much of a runoff because the ground's just going to soak it up. And so you put those together over 20 years of a drought, and that's one of the reasons why the amount of water running into Lake Powell has been so much lower. Now this year, we're really hopeful because we had some pretty good precipitation back in the spring. And so the ground wasn't really dry. We had a tremendous snowfall, depending on where you are, like 150, 174% of normal. And it stayed cold until just recently, just the last couple of weeks. And so we're hopeful that the flow is going to be pretty good this year. And in fact, Lake Powell, the minimum was 335.20 feet. It's been going up a foot a day for the last couple of weeks. Now that's not going to continue for too much longer, but the estimate is it might go up, Lake Powell might go up by 60, 70 feet this year, which would be really great, but it doesn't come anywhere near to filling it up. The estimate is it's going to take maybe another 6, 7, 8 years of snow like we had this year.
The snowball up in Flagstaff is having a record.
Yeah. Yeah. All over the West, they've been records. Yeah. And so we're tremendously grateful. Yeah. Okay. So what happens is that Lake Powell and Lake Mead are the two of the biggest reservoirs in the whole country. And they're both near the level at which we're not going to be able to get much water out anymore. And we depend on that not only for water, but for a tremendous amount of, quote, clean power that doesn't produce any pollutants like sulfur dioxide, and it doesn't produce any greenhouse gases. And if we weren't able to get the power out of Lake Mead and Lake Powell, out of the dams there, that would be a huge impact on the West. Well, yeah. So then you say, well, what else are we going to do if we can't get that? Yeah. So that's, but anyway, so this is where we're at. This is a serious situation in terms of water. Yes.
Do we import water from Canada?
No, not from Canada. Yeah. And the reason is water flows downhill pretty nicely. If Canada was higher than Phoenix and we just had a chute coming downhill, that'd be pretty easy. You might have to pour some concrete, but it wouldn't be that big a deal. But it's got to go over the Rocky Mountains to get here. It takes a lot of energy to pump water uphill. So that doesn't work very well. So here's just a summary. Lake Mead and Lake Powell are about 35 million acre feet deficit between the two of them. If we had about 6 years like we have this year with the runoff that we're projecting, it's not just the snow, but it's a good runoff. Maybe that would help make up that deficit. Other people have said 10 years like this, somewhere between 6 and 10 years of this. So this year was great, wonderful, no minimizing it at all, but it doesn't come anywhere near to eliminating our problem. Now, let me skip over here just a little bit. Here's where we get our water in Arizona. So we get about 36% from the Colorado River through the Central Arizona Project. Now that doesn't go to the whole state. That goes to Phoenix. It goes to Tucson. It goes to some of it goes to Pinal County. Yuma gets a lot of water from the Colorado River. They have the earliest water rights. But you know, if you're in Prescott, you don't get any water from the Colorado River. We get about 18% from SRP, from the Salt River and Verde River, and about 41% from groundwater, and about 5% from reclaimed water. What is that? Effluent. Yeah, water that goes down your toilet, goes to some kind of treatment plant, and it gets treated at different levels. Sometimes it gets treated enough that it can be put on a golf course, but not drunk. That's effluent. Scottsdale has a treatment plant that takes it all the way to drinking water standards. And increasingly, that's probably what's going to have to happen. So
How much energy does it take to get reclaimed water drinkable?
well, it depends on what's in it and what you have to do to clean it up. But not that much, you know, not that much. It's not hugely intensive, energy intensive. It's expensive, but not just because of the energy. They have chemical treatments as well as physical treatments, sedimentation and things like that. And then you have to pump it to wherever it is you want to go. That's what gets expensive too. Phoenix is a little bit different from Arizona as a whole. We get about 52% of our water from the Salt River and the Verde River, whereas only 18% is from in-state rivers as a whole. Now, whoops. There we go. This was a great year in Arizona for snow. And so the SRP dams or our lakes are all full. We had 100% capacity. Actually, it was 104% capacity on Roosevelt Lake. You say, wait, how's that? Is it running over? Well, capacity is not the very top of the dam. They have some flood protection there. And so they've got a little bit more than what their capacity is, on the assumption that they get rid of that. You know, they've got like 30 days to discharge some of it and get it to down. But we were at 100% capacity, which is great. Whenever Roosevelt Dam is full, you can breathe a little bit of sigh of relief, because it means Phoenix is not going to run out of water that year. You know, we've got enough to get us through. We get about 38% of our water in Phoenix from Central Arizona Project, about 8% from reclaimed water, so more than the state as a whole. Because you know, in Phoenix we got a lot of water in pipes, and so you can capture that and do something with it. And only about 2% from groundwater. You go back and look at Arizona as a whole. What's the difference? 41% from groundwater for the state as a whole, and only 2% in Phoenix. Why?
Well, stick it on here. You're getting it from groundwater. There.
Okay, it depends on where you're at, where your water source comes from. But why is there such a huge difference between Arizona as a whole and Phoenix in groundwater uses? Agriculture. We don't have much agriculture anymore in Phoenix. We used to have a lot. We used to have a whole bunch. You know, any of you that have been here for 50, 60 years, remember Mesa used to be farms. It wasn't apartments and all that stuff. But citrus trees and all kinds of stuff. Yeah, cotton fields. So that's the reason why we don't use as much groundwater. So let's talk about that a little bit. We talked about our water situation. If you were the water czar, knowing what our circumstances are, where do we get our water? How do we use it? Oh, one more thing. Here's how we use it. This is in the state. This is not just Phoenix. This is the state as a whole. About 72% of our water goes to ag. 22% goes to industry and about 6% to industry. All those chip manufacturing, they use a lot of water. Now, on their benefit, they recycle their own water. So they reuse it, but they do use a ton. Okay, golf course. Okay.
They bring in all the.
It was nice knowing you all.
Yeah.
Golf courses, we don't live here.
Well, there's some interesting, in the Arizona Golf Association magazine, 2 feature articles this year have been on the use of water. So it's a huge topic, and golf courses are trying to justify their existence and use it more efficiently. But at the same time, they point out, this brings in billions of dollars in revenue to the state too. So it's not all cost, embedded cost.
How much of that is your money?
Yeah. But I think, to answer your question, Larry, if I were the czar of water, I would be taking a careful look at that agricultural use number. And are there more efficient opportunities to outsource some of those agricultural products to areas that could use water more efficiently than apparently Arizona is using?
And if I were the water czar, I want our water back from the Saudis.
Yeah.
I mean, I think
Seriously.
Isn't that an awful?
and all the water they can pump out.
So how in the world can Saudi Arabia come to Arizona and grow alfalfa and then ship it, use our water to grow alfalfa and then ship it back to Saudi Arabia? How does that happen?
They buy the land with water.
Okay, that's the deal. It has to do with the way the law is set up. And so historically, if you own the land, then you own the water below the land. And historically, you could pump all the water that you wanted to. We didn't understand back in the early days that if you pumped a lot of water, you might dry up your neighbor's well because that underground water is connected. And that's happened a lot. But that was the way the law was originally written. What happened back in 1980 when Bruce Babbitt was the governor? People talk about Arizona and, they're talking about crazy things that go on in Arizona and all that stuff. But here's something you can be proud of. Arizona was a leader. Nobody in the country did what we did. Passed the Groundwater Management Act. Babbitt was trying to get this done and they couldn't get it to work. And so what he did was he took the major water users and he put them down at Castle Hot Springs, that resort down there by Lake Pleasant. And he said, nobody's leaving until you come up with a plan. And they locked the doors on them. So this was the ag people, it was the cities, but it was also the mines and it was the tribes, because all those people had a say in how water was going to be used. And what they came up with was a plan that said, we're going to create these active management areas, these AMAs, and we're going to control how much water you can pump. So you can only pump sustainable amount of water. You can't pump it dry, because the problem is if you pump an aquifer dry, an aquifer groundwater, you think about a jigsaw puzzle that isn't put together. You're just starting it. You're putting all the pieces up, but they're not put together. They're close together, but there's little spaces in between them, right? That's what soil particles are like in the ground. And those the void spaces between those particles can have either air in them or it can have water. So if you're just drilling down right near the surface, there's air. That's called the vadose zone. But if you go down low enough, you can get to where it's groundwater. Now, if you're in New Orleans, you only have to go down a couple of feet to get to groundwater. But if you're in Arizona, maybe you have to go down several hundred feet to get to it, depending on where you're at. The problem is if you pump that aquifer dry, though that soil structure can collapse. So those void spaces aren't really there anymore. And you can't refill, even if it rains, you don't regenerate that aquifer. And that's happened. So once you destroy that aquifer, you can't really regenerate it. That's happening not just in Arizona, but one of the biggest aquifer in America is the Ogallala aquifer. Anybody know where that is? Nebraska, Oklahoma, it covers several states, parts of Texas, Kansas, huge aquifer and lots of water underneath that. Farmers started pumping it, and in certain places they pumped it dry.
Land is collapsed.
And the land collapses when that happens. So what they did with the Groundwater Management Act was to say, we're going to control how much groundwater you, even though you own it, we're going to change the law. So you can't just pump whatever you want to out of it. And that has worked pretty well, not perfectly, but pretty well. The problem is not all of the state is an active management area. And so the part where the Saudis are is not an active management area. So there's a big push right now by certain people in the legislature to say we need to expand our active management areas to not allow this kind of pumping that's going on. Just because you bought the land and you're getting all this water for pennies. So that's another example. You can affect the outcome by changing the law. There are two things you can do. You can change technology, you can change the law, or you can change people's attitudes and get them to change their practices. Or all of them. That's what needs to happen. Yeah, all of them. Exactly, exactly.
We had a daughter in California, and you pay more if you go above your water allotment. You get fined, you pay more. So she started turning all her grass into desert landscape, low water use, succulents. She has rain barrels for her rain. She composts her own leftovers, and grows her own vegetables for food. It seems like to me as Christians, we're sitting here thinking, well, what are we going to do? What does that mean for me? We already have Native Americans on the reservation that do not have running water. And PVUMC contributes to water bottles going through. I know this because of I'm Karen, who are connected with the Faith Networks and Flagstaff. We're taking bottles up Flint, the wonderful man, I guess, takes them up there. But taking the bottles of water and plastic is not a long-term solution for them. Seems like to me as Christians first, we need to be concerned about the people in Arizona who don't even have running water to wash their hands and totally affecting the family.
Yeah, washing your hands didn't work very well if you don't have running water. So. Well, so you mentioned, so Dan, you live in the Beatitudes now. If you think about how much water you use, it's basically, what you have in your shower and your sink and your toilets, and that's about it. You're not really, maybe you water a few plants on the patio or whatever, but you don't have a big old lawn in the back that you mow, right?
No, we've got 2 patios, so.
Okay, 2 patios, lots of plants, but all things considered, not very much.
Not very much.
But if you've got a single family home, especially in Phoenix, traditionally, what'd you have? You had a big lawn in the back? You had a big lawn in front, or maybe you had a big lawn in the front and a swimming pool in the back. Most of your water, depending on where you at, but usually a majority of your water was used outside of your home.
I cut it out.
Okay.
I have
So-
a xeriscape for plants, and I have a big watering. And
So-
everything is growing.
Yeah. So if you're saying, what can we do? There are some things we can do. We can do some things as individuals, and that is to say, how do I use my own water? And is there a way for me to still have trees and flowers? We're not talking about just sidewalks, but maybe not an acre of land, a big green lawn that you have to pay somebody to come mow. How about winter lawns? That used to be a big deal in Phoenix. I put in a lot of winter lawns when I was growing up. Looks nice, it's pretty, but it uses a lot of water. There are decisions that can be made that aren't necessarily affecting your lifestyle. You know, they're not saying, well, like, you know, some are easy decisions, like putting in a winter lawn or not putting in a winter lawn.
Yeah, going back to the aquifer in the wells, at 56th and around 56th and the shade area across the Orange Tree Golf Club,
Mhm.
Phoenix just drilled a new well. And I thought that was, yeah, and there's one at 64th and, yeah, it's in 64th and Greenway. Anyway, is Phoenix in, are they?
Yeah, Phoenix is an active management area. So it's not to say you can never drill a well, but they monitor how much water you're withdrawing, and they monitor the water levels and control that.
So they bought this residential lot and just,
Okay.
you know, it's in with all these houses. It looks
Yeah.
very nice.
Yeah,
but it's
Phoenix has
very-
got a lot of wells around, you know, so, you know, they're using groundwater. But interestingly, Phoenix has stored way more groundwater than they have taken out. So one of the things that's happening with their wastewater is they're storing it. And you say, you know, it's not like a big tank. It's not like an underground storage tank at your gas station. They're injecting it into the ground. And there are natural processes that occur in the ground. You don't want to dig that water back up in the well 6 weeks later, but 6 years later, it's going to be clean. Now, you may still have to do some more treatment before you can use it for drinking water, but there's a tremendous amount of water that Phoenix has actually stored. One of the kinds of water, we've been getting Central Arizona Project water ever since the canal opened. We haven't used it all, but we wanted to take our allotment. So what we've done is to store the extra underground for emergencies. And so we've actually not been depleting the groundwater in the Phoenix active management area.
What about the open canals?
Well, the best part about the canals compared to what they used to be is they're now lined with concrete. So it used to be they were just dirt and the ditches were all dirt. And so a tremendous amount of the water that was going down the canals and the ditches was sinking into the ground, never getting to the end user. So the first thing that SRP did was to line most of those canals, and not all the ditches, but a lot of them. And then they put a lot of the ditches underground. They did that for safety reasons.
Most of those grass irrigation?
Well, yeah, so SRP was founded by ag. The way the way Roosevelt Dam was built was that farmers put their land up and they borrowed the money with their land as the equity to build Roosevelt Dam. And that's how it got built. So it started as ag. You know, you can be mad at ag, but if it hadn't been ag, we wouldn't have the dam system that we've had. It wasn't the cities that did that. It was ag that did it. And that's why only certain parts of the valley are covered by SRP water. And if you're, that's why we're north of the canal here. We're not covered by. The problem though is if you're looking at, hey, we've really got to make some major cuts in water usage in Phoenix or in Arizona, you need to go where the money is. Isn't that where Willie Sutton said, why do you rob banks? That's where the money is. So, you know, the fact of the matter is in Arizona, most of the water is being used by ag. So ag is going to have to be part of the solution. They're not going to be all the solution, but they're going to have to be part of it. And that's probably going to mean a whole range of things. Everything from fallowing some land, choosing not to plant, to finding better ways, maybe different crops that don't use as much water, to better ways to water rather than flood irrigation, a drip system of some type. All those things are being tried. We're still in the early stages of that. But that's probably going to have to be part of the solution. On the other hand, if you say, well, why do we have any ag in Arizona anyway? Why don't we just let Iowa have it all? You know, the problem is, do you like eggs? Do you like butter? You know, if we don't have any, you know, most of our eggs and butter or milk is grown locally. And if we don't have anything locally, it's going to cost you more money. everybody seems to go nuts if cost of milk goes up a nickel, it's gonna go up. So there's a price to pay no matter what happens. But there are some things that ag can do, and they're trying. They're aware of this. Nobody's sitting there with blinders. They're aware, but they're going to have to operate differently the way they've done.
Like almonds.
Yeah, almonds are some of the biggest water users of any. You can look at the crop and you can look at how much water it uses, and cotton is another one. Arizona-
For almonds, it takes 3.2 gallons of water. Wow.
Yeah.
Depends on how they're watering.
Yeah.
Yeah.
One of the best places in the world to go to find out how to do that is Israel. They've been doing some amazing amount of innovation in their agriculture because they don't really have rivers. I mean, they got the Jordan River and that's about it. And so they're doing a lot of desalinization of water. I mean, they're near the ocean, so they can get water out of the Mediterranean Sea, but that's really expensive. And so if they're going to use that for ag, they've got to be really efficient in how they do it. And they're among the most efficient farmers in the world. So there's a lot to be learned. And my guess is that, 20 years from now, we look at how much water ag's using and it's going to be, different, a lot different than the way it is now. I hope so. But municipalities can do the same thing. One of the good things about municipalities is, except for the water that we put on our lawns, any water that's flushed or goes down the drain is in a pipe. If water's in a pipe, you can capture it and do something with it. It doesn't have to be just discharged to go down the Gila River. You can reuse it. And you can use it for all kinds of things. Maybe you reuse it for ag. Maybe you reuse it for landscaping, for golf courses. Golf courses don't use potable water anymore, but they used to. Yeah, use it for power plants, all kinds of different things.
Do they collect runoff at the street level?
Well, it goes right now, it goes down, if it goes on the street level, it goes down the storm system, which is in most places, they don't pipe that water into the water treatment facility. It gets piped to the Gila River and goes on down, but it doesn't mean that you couldn't capture it and send it somewhere else. Of course, sending it downhill is easy. Sending it uphill requires power, but you can do it. You can do it.
There's a Phoenix permaculture group that's interested in, and they actually have done experiments where they're capturing water at their residences. But rainwater and harvesting water harvesting, really
Right.
looking at our urban structure,
Right.
looking at our residences
Right.
and how buildings are designed. And even if we don't go that far, just water harvesting can be done by everyone.
Right.
And it can be really effective. And there's several groups within Phoenix that have the statistics, and it's been very effective in creating rainwater.
If you've got gutters on your house, you can harvest the water easy. Yeah. Now it's harder to use that water for a lawn, but it's easy to use for trees or vegetables or shrubs or things like that.
Yeah, and there's a man out of Tucson, Brad Lancaster, who's written books that done research around the world and studied from people in the Middle East. I'll take techniques, so you can actually read in his two very well written books about water harvesting, Brad Lancaster. And then there's Watershed Management Group out of Tucson.
Yes, that's.
And they are fabulous, and they have Hydrate Phoenix, Hydrate Tempe, and you can take classes and talking about, capturing the water from the highest point of your house
Right.
and just make good use of it. It's the cleanest water we get.
Let me just show you one other. Sure. This is put out by the Arizona Department of Water Resources, but what they're showing you is that Arizona is actually using less water now than we used to. Now, the main reason for that is we're not doing as much ag. You think about all those places in the East Valley that used to be ag and they're now apartments, you use a lot less water when they do that. But we're also controlling it better. And this one, before we quit tonight, we're almost at the end, but I wanted to talk about power just a little bit. Where do we get our power in Arizona? Well, we get about 43% from natural gas. This is for electricity generation. Okay. So we had the biggest coal-fired power plant in the Western United States, Navajo Generating Station. It closed down. It closed down for two reasons. One was that it used coal, and the new pollution regulations were going to require APS and SRP to install $1 billion worth of new pollution abatement equipment because it was coal. And secondly, it used to be coal was cheaper than anything else. It was the cheapest fuel. And nowadays it's not. It's actually cheaper to use natural gas. Nobody in the country is building a new coal-fired power plant. And it's not because somebody told them not to, it's because the economics have changed. So we don't have, we still have some coal-fired power plants, but not very much anymore. The other thing here is look at the second largest power source in Arizona, and that's Palo Verde, nuclear. So we have the largest, we're the newest, we were the last nuclear power plant to come online. They're building some now, but they're not actually online yet. So we were the last, that was in the 1970s, believe it or not. And we're the largest in terms of power that's being produced. So now, unfortunately, not all that power goes to Arizona. A lot of it goes to California, but they also help pay for it. And then 13% of our electricity is generated from coal, which is way down from what it used to be, and 9% from solar and 5% from hydro. That's the, excuse me? Well, solar, the cost of solar have dramatically decreased. Now, part of that is due to some subsidies from the government, but that not all of it. The cost of the materials and stuff has gone down dramatically. If you looked at people, I used to teach about this stuff, 20 years ago, and the only way to get people to install solar was to give them huge rebates because it was way more expensive than anything else. That's not true anymore. And there's no better place in the world to do solar than Arizona. I mean, we've got some of the best places in the world. Yeah. Notice that wind is on here, but it's only 1% of our power. But if you go to Texas or Nebraska or other places, it's a much higher percentage. That's just because we don't have that much wind here, at least wind that's productive to produce electricity. So one of the things that's changing these quote green energies, solar and wind, is their costs have gone way, way down, and hopefully will continue to go down to the point where it's cheaper to build them than a fossil fuel. Why are we worried about fossil fuels? Why are people concerned about fossil fuels? Fossil fuels is coal, oil, natural gas. Why is that a concern? Okay, that's one reason. Yeah, there's only so much coal in the ground. There's only so much oil in the ground. We keep finding more oil, but in order to find it, we have to go way offshore and we have to go way down deep, and things we never used to be able to do. We used to say, here's how much oil we have. But that was, the old Texas, drill, thing, we go down a couple hundred feet. Now we're going out in the ocean, we're horizontal drilling, doing all kinds of things. So the amount of oil that's out there is not a static number. It changes depending on the technology we have, but it is finite. We're not making any more oil. It takes millions of years to do that. So whatever's there. Really? Yeah.
There's still some left, but.
Yeah.
Yeah.
Yeah, the other thing about oil, yeah, oil is a world market. So, we say, well, we can be energy independent, but when we drill oil, it goes on the world market. And if the oil companies can make more money selling it to China, they'll sell it to China. They dig it in Pennsylvania and sell it in China. Now, you can say, I don't like that. I want to pass a law that says all American oil has to, but anyway.
Cost of air and water.
So there's two or three reasons why we're concerned about fossil fuels. One is it's a finite resource. That's true. We may have a lot of it, but we don't have an infinite amount. And a lot may be another generation or 2 generations, but not 10 generations. The other is that it's dirty in the conventional sense. Why did we have all that dirty air? Because we were burning coal, we were burning oil without all the pollution control devices and stuff like that. It's a dirty fuel. Yeah. And so if you're going to use it, you have to put a lot of pollution abatement cost into it. And that adds to it. We don't want to go back to the era of the 1960s. But what's a new reason why we're concerned about it? When I was in college, I was never concerned about carbon dioxide. We talked about you burn something clean, and it burns to CO2 and water, and isn't that wonderful? And then all of a sudden, people began to get concerned about CO2. Why would they be concerned about CO2? I know we're running out of time, but let me do this quickly. When the Earth is absorbing radiation from the sun, it's coming in from the sun mostly in the visible and the UV range. Some in the infrared, but mostly in the visible and the UV. But when we radiate into space, all of that energy going back into space is going out as infrared radiation, much longer wavelength. Now, why does that make a difference? Carbon dioxide, is that a colorless gas or colored? Is it pink, purple, red, or it's colorless? Breathe out, everybody breathe out. You're all breathing out carbon dioxide. It's colorless gas, doesn't absorb visible light, but it does absorb infrared light. And so the problem is when we're putting a lot of carbon dioxide into the atmosphere, some of that carbon dioxide is absorbing this infrared radiation that's escaping the Earth. It's trapping that infrared radiation, not letting it escape the Earth. What does that do? It warms it up. That's called the greenhouse effect. So the carbon dioxide's acting like the glass in a greenhouse. It's not a physical piece of glass, but it's absorbing some of that radiation, not letting it escape. And so inside that glass, it's warmer. And the more carbon dioxide we put in the atmosphere, the warmer it gets. That's a good thing. If we didn't have any carbon dioxide in the atmosphere, the Earth would be about minus 15 degrees Celsius. It'd be a frozen wasteland. There might be life on Earth, but it wouldn't be life like we know about it. So it's a good thing we have some carbon dioxide in the atmosphere. The problem is, how much do we have? Well, we've been measuring carbon dioxide every year since 1958 in Mauna Loa, Hawaii. And so we've got a record, an accurate record of what the carbon dioxide concentrations have been since 1958. Started in 1958 at 315 parts per million, way down here. And what is it? Whoops. What is it now? April of 2023, it was 421 parts per million. You say, well, parts per million, that's not a lot. But from a percentage standpoint, how much have we increased that? From 315 to 421. Don, you're the mathematician. A third. Before that, we can do some ice sheet data and we can estimate what the CO2 level was pre-industrial times. And it's about 280. So before we started digging up all this fossil fuel, coal and oil, and burning it, it was about 280 parts per million. And now it's 421, more than half. Well, is that a problem? I don't know. But look at this data. This goes back 800,000 years. Now, that's not back to dinosaur era. But in the last 800,000 years, we really haven't been above 300 parts per million. Where are we now? 421. Now, I don't know exactly what that means, but that's a little scary. And there's no other reasonable explanation for why that CO2 level has increased, except for the fact that we dug up all this fossil fuel and burned it. It's not magic. You dig up coal, you dig up oil, it's mostly carbon, you burn it, it produces carbon dioxide. How much have we dug up? A lot. That's how come it's increased so much. I mean, breathing out? Well, not, yeah, I mean, maybe, but not as much as digging up the fossil fuel. Yeah. So that's why we're concerned. And that's what people are talking about when they say we need to reduce our dependence on fossil fuels. Now, are we talking about reducing it next week? No, nobody's talking about it. But if solar is coming down, if wind is coming down, if we can figure out, and nuclear doesn't generate any fossil fuels. It's got some problems. We haven't figured out what to do with all our nuclear waste. We were going to send it up to Utah and bury it. And then Utah decided they didn't want us to do that. So we stopped doing that. There's a place called Yucca Mountain in Utah. That's where we're going to send it all. But so that's a big problem. And terrorists stealing some nuclear fuel, that's a problem. But from a greenhouse gas standpoint, from a climate change standpoint, nuclear doesn't generate any greenhouse gases. So there's different opinions about that, but from a greenhouse gas standpoint, it's another source. So that's the thing that we have. And I said I had some good news and some bad news. The good news was on the conventional pollution front, we've done things. We have made decisions as a whole. We passed laws, we've spent money, we've generated new technology, and we've improved things. From a climate change standpoint, we haven't really done much yet. We're still in the talking stage. We're still back at that picture of the Cuyahoga River on fire saying, maybe we ought to do something about this. But we haven't actually done a lot. We've talked about it. And countries have said, we're going to do something about it, but we haven't bit the bullet and done a whole lot yet. Now, there's a lot of different opinions about what ought to be done and very valid differences of opinion about what the right thing to do is. Because there's not just one answer to it. That's maybe the subject for another discussion. Too. Yes, please.
I was going to say I always like to be kind of the devil's advocate.
I know. That's why we like you.
but one of the things that's missing when we talk about the amount of CO2 in the atmosphere, I don't have any disagreement as far as it's been increasing. It absolutely has, but you have to look at CO2 is still not the dominant greenhouse gas. The dominant greenhouse gas is water vapor.
Yeah.
So you've got to look at the quantity of CO2 versus the quantity of water vapor. You've also got to look at the absorption coefficient of both of those devices. And it's like, methane, is you can have less of that, and that's going to it doesn't stay around as long, but it has a higher absorption coefficient, if you will. So
that's absolutely true. That's absolutely true.
So I mean, this whole thing, it's very complicated. It's not simple, and unfortunately, to me anyway, it's a fascinating subject. It's a very interesting subject that unfortunately has become so highly politicized that it's hard to have a intelligent conversation about it anymore. And I really appreciate your presentation, because I think you had the facts you present are really good, and it's I think it's something that we need to be aware of. Yeah, I'll tell you, the water is a little simpler than the carbon dioxide. That's kind of where I come from.
It is absolutely true. There are a number of different what we call greenhouse gases. The two most important are water vapor and carbon dioxide. And water vapor is actually present at much higher levels in the atmosphere than carbon dioxide. We just said carbon dioxide is 400 parts per million. Water vapor, depending on where you are, is percent quantities, depending on the humidity. It could be 2%, 3% of the atmosphere is water vapor. And that also traps some heat because it absorbs infrared radiation. The difference, though, is that humans haven't really, most of the water vapor that's in the atmosphere is evaporation from the oceans and from surface water. There's not much that humans are doing that are changing the amount of water vapor that's in the air.
Right.
When we burn gasoline in our cars, we produce carbon dioxide and water vapor coming out of the tailpipe of the car. But that's not very much contribution compared to the amount of water vapor that's evaporated from surface waters. But there are greenhouse gases like methane, like sulfur hexafluoride, other kinds of chemicals that are used from industry standpoints, and all of them can contribute. So it's a complicated issue. There's not a simple answer. And I, in the future, it'd be fun to talk about, well, is it really the best solution to do this or do that? We don't have time to do that tonight, but we've got a lot of potential things we can talk about. But I just, I do want to leave you with this thought, and that is, I think the history since 1970 of how we've dealt with conventional pollutants should encourage us. It shows us that if we put our mind to it and we are, willing to take time and effort, we can solve these kind of problems. And I believe we can solve the climate change problem. I don't think it's insoluble, but unfortunately, we've got to come together. We've got to figure out a way for us to work together. Even with people that we don't agree with totally, we still got to find a way to come together in a better way. So maybe as a faith community, we can help lead doing that. So thank you all.
Thank you so
Thank you all for
much.
coming online. We appreciate you.
Yeah.
Bye-bye. Good night.
Good night.
How does one access the tape?
We're going to check with Jeremy.
We're gonna upload it to YouTube. When you